Okay, so we will start again. This is the part 2 of Ahmad Zaheeruddin's book. The value of structural geology, the value of theta, the angle between the fracture surface and the direction of greatest principal stress, sigma 1, for most of the shear fractures is determined by the expression theta is equal to 90 degree minus pi. Theta is equal to 90 degree minus pi by 2. The uh, critical shear stress increasing necessary for fracturing to occur in a rock under compressive stress conditions is governed by Coulomb's law. The envelope in the Moore diagram of shear fracturing in a rock under compressive stress condition above the brittle ductile transition, that is the linear relationship between fracture strength and confining pressure is lost, is called von Mises failure envelope. The shear fractures under compressive stress condition in a rock in brittle ductile transition makes an angle theta greater than 30 degree with respect to direction of greatest principal stress. Based on the geometry of the Moore diagram, most rocks in nature possess the internal friction angle of about 30 degree. If the principal stress directions are vertical or horizontal and the angle of internal friction is 30 degree, which of the following faults will form at or near the Earth's surface? Normal slip, strike slip, thrust slip. Strike slip faults form when sigma 2 is vertical. The unit of stress, megapascal, is MPa is megapascal. Thus, a stress of 254,000 Newton per meter square is equivalent to 254 kilopascal. 1 kilopascal is equal to 1000 pascals. 1 Newton per meter square is equal to pascal, 1 pascal. So 1000 Newton per meter square is equal to 1000 pascals or 1 kilopascal. So 254,000 Newton per meter square is equal to 254 kilopascal. If the hanging wall if the hanging wall of a high angle thrust fault has moved up while the foot wall stayed in place, the fault is called upthrust. An isolated patch or outcrop of younger rock surrounded on all sides by geologically older rocks is called outlier. Clippe is a form of outlier. Inliers may be formed by both B and C, anticlinal vein and post. Post is the top part. Graben is the lower part. Upper part is like the raised part is host and the lower part is graben. An unconformity in which lower rocks are of igneous rock mass like granite is called nonconformity. Which of the following faults is or are strike slip faults? Branch faults, tear faults, transverse faults, all of these are strike slip faults. Which of the following faults are parallel to the regional structure? Drift faults. A fault in which the strike of the fault plane is essentially normal to the strike of the adjacent beds is called dip fault. In thrust faults, crust shortens. The net slip is measured along fault plane. Which of the following faults is not a dip slip fault? None of the above. The strike slip faulting is accommodated by both A and B, so shortening in horizontal plane and stretching in horizontal plane. In translation, along right-handed and left-handed strikes, slip faults are balanced. Then the strain is coaxial. In thrust faults, the fault plane dips less than 45 degrees. Which of the following equations is the fundamental strain equation? Ramsey 1967, which determines the stretch and shear strain for any line of any orientation in a strained body. Lambda dash is equal to lambda 3 dash plus lambda 1 dash by 2 minus lambda 2 dash minus lambda 1 dash by 2 cos 2 theta d. The fundamental equation of ratio of shear strain to quadratic elongation, that is gamma by lambda, which describes the mixture of change in angle versus change in length in a strained body, is gamma by lambda is equal to half into 1 by lambda 3 minus 1 by lambda 1 sine 2 theta d. The lines along which the value of gamma by lambda approaches zero are characterized by change in length with very little shear strain. Which of the following equations is the fundamental stress equation to calculate the normal stress sigma n on any plane of any orientation? Sigma n is equal to sigma 1 plus sigma 3 by 2 minus sigma 1 minus sigma 3 by 2 cos 2 theta. Which of the following equations is the fundamental stress equation to calculate shear stress sigma s on any plane on a plane of any orientation? Sigma s is equal to sigma 1 minus sigma 3 by 2 sine 2 theta. The normal stress sigma n at a point oriented plus 30 degree when sigma 1 is equal to 40 megapascal and sigma 3 is equal to 20 megapascals will be 25 megapascal. From the Mohr stress diagram, we can determine the orientation of the plane relative to sigma 1, greatest principal normal stress, value of normal stress acting on a specific plane, value of shear stress acting on a specific plane. The radius of the circle of the Mohr stress diagram represents deviatoric stress. The deviatoric stress is the non-hydrostatic component and tends to produce distortion. The differential stress in the Mohr stress diagram is represented by diameter of the circle. When all the three principal stresses are non-zero, but two of the three principal stresses have the same magnitude, that stress is known as axial stress. Which of the following conditions either are true in case of triaxial stress acting at a point? It is E. E is all of the above. All principal stresses can be compressional, right? All principal stresses can be tensile. There are no restrictions regarding whether the principal stresses are tensile or compressional. There can be combinations of both the stresses. So all of the above. Uniaxial hydrostatic stress, triaxial stress, axial stress. This is A2, B1, C4, C3. Axial stress is 3. This is axial stress. Triaxial is this C4. C4. B was 1. Hydrostatic stress is this 1. And uniaxial is this 2. The critical shear stress necessary to cause reactivation of an existing fracture is equal to the product of coefficient of sliding friction of the rock and normal stress acting on the fracture surface. Coefficient of sliding fraction expresses the ratio of shear stress to normal stress on the fracture surface at that in the instant that sliding initiates. The law that describes the initial stress necessary to cause reactivation in a rock is called Bailey's law. The mechanics of fracturing of the rocks is strongly controlled by intragranular cracks, transgranular cracks, intergranular cracks. The amplification of the stresses at tips of micro cracks depends on orientation, length, and width of the micro cracks. Which of the following is associated with crystal fiber vent? Anti-axial vents, syntaxial vents, crack seal vents. Oh my goodness. I think all of them. Again, it's all of them. 76. All of the above. Okay. Which of the following is associated with crystal fiber vein, anti-axial veins, syntaxial veins, crack seal veins. In syntaxial crystal fiber veins, outside in, and the mineralogy is same as that of the wall rock. The preferred orientation for micro cracks formed in tension is parallel to sigma 1 and perpendicular to sigma 3. Okay, again we'll keep it till this much and continue with the next part.